Here's an interesting article titled Network Monitoring with SMS. Network troubleshooting is always a complex task for a system administrator. A myriad of problems can occur on your network, including problems with the network's physical layer, that's wiring, or problems with the NICs running on each machine, and even problems with the logical layer. Diagnosing the exact problem is often a time-consuming trial-and-error task. To diagnose problems, system administrators generally use a network monitoring tool, sometimes known as a protocol analyzer. These devices can either be hardware or software that lets you review all the packet traffic. Okay, so I'll skip that entire first few paragraphs of this article because they don't really say much beyond just introducing a protocol analyzer, which they say can be hardware or software that lets you review all packet traffic. So pretty fancy name for a pretty simple concept. Now they do say that basic hardware and software network monitoring tools do not provide diagnosis capability. They often collect only statistics and packets that you must manually sort through to figure out a problem. Advanced, multi-$1,000 hardware devices use built-in artificial intelligence to determine what, if any, network difficulties you have. Microsoft back office users do not need to spend thousands of dollars on a network monitoring solution. So I made bold and underlined that word because that's the name of a product. The systems management server component of back office includes one. That is a networking monitoring solution. Unfortunately, many administrators are unaware of this feature and its power. Because it is not adequately documented in reference sources, third-party SMS, books, or training videos are available from a variety of sources. The network monitor lets you observe dozens of different protocols traversing your network. These protocols include basic ones Microsoft products use to communicate with one another, such as Server Message Block, SMB, for file sharing, and other protocols such as DHCP. The article then goes on to identify quite a few other protocols. Let me skip down to this part where it says, for NetWare-enabled environments, the network monitor lets you watch NetWare Core Protocol, which is abbreviated NCP, and then they also list out IPX and SPX traffic. So where is it? When you install SMS, the network monitor component installs on your back office server by default. You can manually choose not to install the component, by the way. To verify the presence of the network monitor, look in the SMS menu from the Programs option on the Start menu, or look in the SMS program group if you're running NT 3.51. Before you use the network monitor for interactive debugging, you must install the network monitor agent. Unless you insert this agent into your system's network configuration, you can use the network monitor only to view the contents of capture files from other machines that have the monitor agent set up. To use the network monitor, you must have a NIC that supports promiscuous mode operation. In promiscuous mode, the NIC routes all packets it sees on the network to the controlling network driver. Ordinarily, a NIC disregards any network traffic that does not have the NIC's media access control address. And there with media access control, they have it abbreviated MAC. Typically, if a packet does not have the correct address, your NIC will not route the packet to your computer's network device driver. Wow, what an interesting and useful explanation of how promiscuous mode works. So without this, the card will discard the packet. You can launch the network monitor in two ways. In the first method, select the SMS network monitor option from Systems Management Server Programs menu in NT 4.0. The network monitor will launch with no filtering defaults, or launch the network monitor within the SMS administrator by double-clicking the network monitor option when you're reviewing a personal computer's properties within the SMS administrator. When you first launch, the monitor information overload occurs. The main network monitor window, the capture window, appears and displays information regarding the network adapter the monitor happens to be observing. If your NT machine is multi-homing, i.e. you have more than one network adapter, switch between the adapters to make sure you're monitoring the correct network. The capture window consists of 4 panes: total statistics pane, graph, station statistics, and session statistics. and gives you an overview of network performance and information on the monitor's capture status, as screen 1 shows. Okay, so let's immediately go to screen 1. We can look around. Sorry for the bad quality. Network monitor, Ethernet. Here we have percent network utilization, frames per second, bytes per second. Down here is network addresses. So 1 and 2. Down here we have frames sent, frames received, bytes sent, bytes received. How many of you watching have used Wireshark before? And let me give you a quick sneak peek at screen 2. This is the frame viewer window. And then notice the hexadecimal down here. They say before you can collect network performance statistics, you must specify a packet filter and tell the network monitor to start collecting packets. A packet filter is a set of Boolean rules to tell the network monitor the packets you want to capture in the capture buffer and compute statistics with. Packet filters have 2 components, an origin address and a destination address. You can collect all packets that you plan to send to a particular address or those that originate from a particular address, or any combination of the 2. You can also use a wildcard, any, to specify any address. By default, if you start the network monitor directly from the start menu, network monitor will use the any wildcard for both inbound and outbound packets. If you start from the SMS administrator, the packet filter will select packets only for the particular machine you specify. Now they say with the graph pane, you can quickly assess which category network activity originates from. For instance, if your network shows a high percent of utilization, you can use the graph pane to examine traffic classification. Is the traffic normal or showing a large number of multicasts or broadcasts? With the data on the bar graphs, you can determine the type of traffic on your network. For example, if you see high utilization but a high number of broadcasts, determining and correcting the broadcast problem will improve performance. To identify stations consuming a great deal of network bandwidth, refer to the station statistics pane. This pane summarizes all traffic on the network on a station-by-station basis. It shows the network address, number of frames sent and received, etc. Now they do point out a potential problem, and that is segmented network traffic. If you segment your network using an Ethernet switch, the network monitor will see only packets that transmit over the leg of the network that the monitor is physically connected to. Again, this data might show an apparent decrease in the amount of traffic, especially if you use workgroup features on a segmented leg of a network where you don't run the network monitor. To combat this problem and obtain more precise statistics on your network's performance, install monitor agents on qualifying client machines on each leg of your segmented network. You can then interrogate and collect the statistics from those agents with the centralized network monitor utility. And they finish the article by saying, even with these caveats, SMS's network monitor utility is powerful and flexible. A network administrator will find it helpful in diagnosing network problems. Thanks for watching.